Today we're going to talk about converting from base B to base 10. And when I reference base B, I mean any number that's a different base than base 10. For instance, let's say I had the number that was 10001 in base 2, and I wanted to convert to base 10. The way that we do this is we use the fact that every base starts out with 1, and then the base unit, and then the base unit squared, and then cubed, and then to the fourth, and so on. And this pattern continues. 1 is 1 regardless of what your base is. But if I'm talking about base 2, I have pairs here. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And 2 to the fifth is 32. And I would continue in that pattern as I move larger and larger and larger. So whenever I have a number, say 1001, what that means is I have 1, 8, I have 0 4s, I have 0 2s, and I have 1 1. Essentially, I take this number times whatever the base is at that point, plus this number times that base value, plus this number times the base, plus this number times your base. Or 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1, which is the number 9. If you think about this in terms of exploding dots, if I had exploding dots and I was working my way backwards, where in my diagram I have a dot here and a dot here, this first dot, when I move it back here, doubles. Because we're talking about base 2. We are unexploding these dots. Taking these 2 into the next box doubles to 4. 1, 2, 3, 4. Taking those 4 into the next box doubles to 8. 1, 2, 3, 4, 5, 6, 7, 8. So the base 10 number that I start with was 9. Now, we want to have that method to be able to do this without drawing the pictures out, which is where this system of using bases works for us. Let's do base 2 again, and we'll do the number 110101. We have 6 numbers here, 1, 1, 0, 1, 0, 1. And without drawing the dots and exploding it back out, where do we go from here? Remember that the furthest right is always a 1, and then the next number is always the base. And then we use exponents to increase, doubling in this case. This is 2 squared, 2 to the third, 2 to the fourth, and 2 to the fifth. Or 32, 16, 8, 4, 2, and 1. As you can see, we are doubling each time we increase. I've got 132, 116, 0 8s, 1 4, 0 2s, and 1 1, which works out to be 32 plus 16 plus 0 plus 4 plus 0 plus 1, or 53. 53 in base 10 is the same thing as 110101 in base 2 or binary. If I wanted to use a different base, I'm talking about base 3, it's the same idea. I'm still doing 1, and then the base squared, the base cubed, the base to the fourth, and so on. That would make this 1, 3, 9, 27, 81, and you would continue on up. With 212, that means I have 2 9s, 1 3, and 2 1s, or 18 plus 3 plus 2, or 23. Hope this helps you learn how to convert from any base to a base 10 number.